Okay, so we're coming back to this now. I'm going to add another column here for my ordered pair. So I think I'll just kind of start over on my table and kind of get it organized a little bit better for you. So this is going to be your ordered pair. This is that objective function again. Remember, the medical kit is going to help 6 people and the water container helps 10. All right. So our ordered pairs are going to be 0, 0, and then this point up here, which is 0, 4,000, 4,000, 2,000, and then 1, 2, 3, 4, 5, 6,000, 0. Okay, we're going to take each of these ordered pairs and plug them in. So, of course, if I plug in 0, 0, I get 0 for my value. In other words, I didn't help anybody. If I put in 0 and 4,000, I'll end up with 6 times 0. Let me rewrite that for you. Looks like 60. And 10 times 4,000 is 40,000. If I put in 4,000, 2,000, got one too many zeros in there, you'll get 24,000 plus 20,000, so that's 44,000. And if you put in 6,000, 0, you'll get 36,000. 6 times 6,000. Plus 10 times 0. So your goal is to help the most number of people. All right, so the questions were, how many of each should be sent to maximize the number of victims aided, and how many victims are going to be aided? So, okay, here we go. This is the solution to your question. 44,000 people. Let's see. Or victims will be aided by sending 4,000 medical kits and 2,000 containers of water. So we answered both questions there with this statement. We're going to do another one. We're going to set up number 87, which is on page 571, so you can see how that one works as well. Okay, it says an office manager wants to buy some filing cabinets. Filing cabinet A costs $10 and requires 6 square feet of floor space and holds 8 cubic feet of files. Cabinet B costs $20, takes 8 square feet of floor space and holds 12 cubic feet of files. Okay, let's pause right there and let's let X be cabinet A and let's let Y be cabinet B. All right. He wants to spend no more than $140. So right there we have information about money. We also know that these will stay positive. We know that the number of cabinets can't ever be negative. All right, so he can spend at most $140. Cabinet A is $10, so 10x. Cabinet B is $20. And he has to stay underneath $140 or equal $140, no more than. He also has room for no more than 72 square feet of cabinets. So let's see, cabinet A takes 6 square feet and cabinet B takes 8. And we need to stay under 72. All right, I'm going to set up a table for each with intercepts. So I let x be 0 and y be 0. They take turns. When y is 0, I'm going to take 140 divided by 10. And when x is 0, I'll take 140 divided by 20, which is 7. For this one, okay. 72 divided by 6 is 12, and 72 divided by 8 is 9. And then we need to graph. Okay, you're going to have to come up with the scale again. That's reasonable. I think I'm going to count by twos. 2, 4, 6, 8. Make sure I didn't skip any lines. All right. So 14, 0. 0, 7, 2, 4, 6, 7. And you guys will probably need to use a ruler there. 12, 0, and 0, 9. 2, 4, 6, 8, 9. All right, that point of intersection, again, for me, it's going to be hard to find because my lines aren't straight. So I'm going to go ahead and do my substitution or elimination here on the side to see where my lines intersect. I think I'm going to make these both 30s, so multiply by 3. And by a -5. Let's see, 72 times 5. -360. So y is 3. And so that makes x 8. So this is the 0.38. All right. These are less than, so you're going to be shading below. So this becomes the region. Now, you can also do test points to see where to shade, but shading below does come from what we did yesterday where we were looking at shading above or below. So you can do test points to figure that out, or just realize that when it's less than, you're going to be beneath. Okay. My last video here is going to set up the table for the constraint function, and we'll find the maximum and minimum amounts that he can come up with for his office, and we'll answer those questions.